Welcome to Electronics Techie. So in this video, we are going to discuss about the SR flip-flop. So how we are going to design these SR flip-flop using Verilog code, just we have to see this. So first of all, you have to know that truth table or excitation table of the SR flip-flop. So if you don't know about what is the design and how it is going to be work of SR flip-flop, you can comment on it and make separate video how the SR flip-flop is like that. So in this video I am just going to discuss about only the design code and test bench code and how it is going to be get the waveform by using the inputs. For that I will consider some excitation table simply here. So if you want detailed explanation you can comment on it. So this is our S, R and Q and this is our next state. So it is our Q1 and it is our next state. So present state, next state. So 0 0 combination. So 0 0 0 0 1 1 0 1 0 1 1 1 1. So 0 1 0 1. This is our truth table or functional table of the SR flip-flop. So for this, what is our output we are getting? So no change state. So whatever the inputs, it directly pass to the next state. So for the next one, should be 0. So for the next one, it should be 1. For the next, it will be invalid. So this is our SR flip-flop. You all know about this. So for first condition, so our value will be no change. For the second two, our value will be reset state. So for the next two states, our value will be set. And the next two is invalid states. We all know about this functional table of the SR flip-flop. By using these functional table, we are going to design this is our functional table. So by using this functional table, we are going to discuss about the design code. So just see how you are going to start your design code means you have to start with module. So module followed by module name. So this is called by module name. You have to write the module name here. So SRFF is your module name. You can use any module name according to your understanding. So what are the input ports we have? So for D flip-flop, clock is our input. So we can take positive or negative edge. So here we consider I consider positive edge. So clock and the reset. What are the, means when you are going when your reset value is going to be 1, then your flip-flop is going to be start from beginning. So like that. So and next are two inputs. So we can draw like this. So this is our clock. So S, R is our inputs. Otherwise you can simply draw it. Minute. So we can simply give the two inputs here. So this is our S, this is our R. So this is the clock. So we have to Q and Q bar. So this is our SR flip-flop. So output will be the Q, means we are going to use this Q in reg data type. So the means you are going to use this Q in always block. So when you are going to use the variables in procedure blocks, means always are initial blocks. So you should be make it as a reg data type. So that's why I make Q as a reg data type. So after that what you are going to do means, so we have to write the always at the rate pause edge clock, means always. So whenever there is a change in the sensitivity list, then the whole block is going to be executed. So here you can write always. How it is, the syntax is always at the rate. So this is the sensitivity list, means whatever the variables we are assigning in this parenthesis, so that should be the conditional statement for all this block, means whenever there is a change in this particular variable what you are assigning in the sensitivity list, then only your always block is going to be executed. If there is no change in the clock, then there is no execution in this block. So if there is a change in the clock, means positive edge of clock, means we can say this is our positive edge of clock. So whenever there is a change in the positive edge of clock, then only this block is going to be executed. So there is a negative edge, then there is no change. Whenever again the positive edge is going to be happen, then only again this block is going to be executed. So then followed by begin. So if of reset, means if the value of, it means reset value. So what are the reset value you can consider here or here. So what is the reset value of the flip-flop is going to be 1. Then the whole flip-flop is going to be the initial state, means 0 state. So that's why I have to assign the next Q value is going to be 0, means our output is going to be 0. So next, if the reset is not 0, means if the reset value is not equal to 1, so then what will happen? So that's why use else block here, else begin. So if the reset value is not equal to 1, then this block is going to be executed. case of S comma R means S of means it is the concatenation. So what are the values you are going to give? So the first bit is going to be assigned to S and second bit is going to be assigned to the R, like that. So if the SR values is 0 0 means, see here, if the SR values are 0 0, so then what is our output here? We can Q is assigned to Q only, means Q is directly assigned Q is directly assigned to Q. So means present state equal to next state. So that's why we can written like this. So for SR value is 0 1. So here you can observe in the functional table. So SR value is 0 1. Then our Q value is assigned to 0. Means here you can observe the next state is going to be 0. So Q is assigned to 0 by using non-block statements. So block in the previous video, whenever I explaining about sequential circuit code, SR latch, like that. So then I discuss about these non-blocking and blocking statements. And upcoming videos I definitely make a what is the difference between the blocking and unblocking. So until then we can simply remember that. So non-blocking statements are execute parallelly, so concurrently. So whereas in parallelly. So whereas in the combinational circuits we are going to use the block statements. It will be going to be execute serially. So like that. So see, for SR value is 0, 1 0 1 0, you can whatever the values of SR value is 0 1, then our output is going to be 1. So next, if the SR values is 1 1, so it will be the invalid state. So you can represent with x x. You don't simply represent with like x like this, means it will be give some error. So it should be represent like 1 tick b x. So y means x is considered as a variable. When you can give this like this, then only it considered as a number value like. So case, whatever the case we are using in this keyword is end with this end keyword, end case keyword. So there is a else begin here, so that's why I have to stop that one. So we have to end here. So whatever the always begin here we are using, so we have to end that with this end keyword. So module end with end module. So have whatever the beginning, there is a ending statement. This module end module. So this begin, whatever the begin here, it will be end here. So begin and case will be end case. So these are the connections. So we have to make the block inside this begin and end like that. So how to end that one, otherwise it will be going to be terminate and make some error. So see here, it is our test bench code. So our test bench code is simply like we are giving to inputs, we are giving some values to the inputs and cross check whether your output is going to be correct or not. So we have to observe these here. So this is our module name. So this is a module star followed by module name here. So you have to make any module name. So it not should be equal to your design code module name, because you can't take same module name, because you get when you are going to instance it may be some clumsiness. So you have to take different name according to your design name. So then we have to make the input variables as the reg data type. So output variables as a y data type. So why you make only reg or y means, so what are the variables we are going to use in the initial block, that should be in a reg data type. So I already discussed every time. So whatever the initial and always blocks is going to be execute means, these should be what are the variables we are going to use, it should be a reg data type. So that's why make it as a reg, otherwise you can take as y data type also. So SR flip-flop. So you have to instantiate here. So you have to connect the instantiate is nothing but you have to connect the two modules. So what you are going to do here, so you have to connect the design code with test bench code. So you have to connect the design code with test bench code, means then only your design code is get connected to your test bench. Then what are the values you are going to your design, then it will be taken by the test bench. What you are going to give in the test bench, it should be taken by the design code. Then your values are going to be processed there, and the output is again the design code is giving to the test bench, and test bench will going to be execute our output values. This is, so you have to connect the design code and test bench code. So this is the main line you have to connect the by design code or test bench code. So how you are going to connect this? So first you have to write the design code module name. So this is our design code module name. So you have to write the design code module name here, followed by instance name. So instance name is nothing but we have a specific name. You have to make any name here. So so it is a syntax. So here I use DUT, means design under test. You have to write your name also, but according to some professional, so you have make it as a DUT, and again port list. So you have to connect the ports, means. So this is our design code. So there is a design code, there is a clock, what are the values, reset, S and R. So this is our Q is our output. So we have to connect this test bench variables. So what are the variables inside the test bench, outside the test bench? So that should be connect. We have to connect these wires, means Q is again connected to the test bench Q. So these are the variables of test bench. So what are the inside variables are design code variables. So we have to connect these two variables. So how we are going to connect means by using this port list. So this is the port list by order. So how we are going to connect the port list by order means, so here we can observe the order of the ports. So first is clock, reset, S, R and Q. Same order is mentioned in the same here also, clock, reset, S, R, Q. So means, so first what are the variable? So what is the variable? Clock here. So it should be connected to the first variable in the here. So clock is connected to clock. So if you write like reset comma clock comma like this, so here what will happen means, what are the clock here, so this clock is going to be assigned to the reset. So because there is a first one is clock, this is a first one is reset, so that's why it going to be connect. So must and should careful about port connection. Port connection by name I also discussed in previous separate video. I make some separate video about port connection. So if you don't watch it, go through that, then you can easily understand the port list, how you are going to connect the ports by using by name or by order, which is better, which is suitable, when it is more efficient, when it is good, at which time it will be going to be applicable, like that. So everyone I am discussed. So this it takes long time when I make more explanation here. So this is the port list. So we have to connect the input and outputs of design code with test bench code inputs and outputs. So this is our initial block. So in this initial block only we are going to give different input values and cross check those outputs according to your functional table in the waveform. Then only you can say that your whatever the design is correct or not. So see here, first initially I give clock equal to 0, then reset equal to 1. So if the reset equal to 1, so it doesn't care about what are the variables we are given. It should be simply make it as a q is equal to 0. So then after 10 nanoseconds, our reset value is going to be 0. Means after 10 nanoseconds, your flip-flop is going to be ready to execute according to your inputs. Until then, what are the inputs? It should be a 0 value only. So here I forget about default case. So default means, so if it is not 0 0 0 1 1 0 1 1, so it may be 1x or 0x or x0 x1. So your combination is simply like this. So then it defaultly consider as it is a default case and make it a value as unknown. So that is the default value when you are going to use the case statements. So I forget that line, so that's why I mentioned again. So here you can see 10 nanoseconds after our S value is equal to 1, R value is 0. Again some delay. I give again some different combinations of SR. Again some delay. I give different combinations of S and R. And again some delay. I give some different values of S and R. Sorry, this is the R value maybe. But if you give S value means it will be override this S value and it will consider R value as previous only. See here all equal to 0 and S equal to going to be 0 is overwritten by 1. So here is the combination it is going to be execute. So after 20 nanoseconds of the delay, I finish the execution. So end. So your clock is going to be not 0 only. So it will be toggle like this. So 0 1 0 1 0 1 0 1 like that. So that's why we have to write this line. So how we are going to write means always. So always means every time. So in the name itself, 5 delay means every 5 nanoseconds of time your clock is equal to invert of clock. So if 0, here is clock equal to 0 for 5 nanoseconds. So after 5 nanoseconds your clock will be toggle, means 0 invert of not of 0 is nothing but 1. So here after 5 nanoseconds it is going to be 1. So again after 5 nanoseconds it will be going to be toggle. So like this it will be toggle for every 5 nanoseconds. If you give 1 nanosecond here, so it will be toggle for every 1 nanoseconds. According to this delay, this is going to be toggle here. So these 4 lines are going to be used in the EDA playground. You have to get the waveform. I already discussed how you are going to use the EDA playground like that. If you don't watch, go through that video. Then you can easily use the EDA playground if you don't know about that. So these 4 lines are going to be get the waveform of the say design code or test bench code in the EDA playground. So followed by end module. So this is our test bench code. So this is our simulation. You have to observe here. So see here first one. Your what are the values of means it is the passage of clock, means whenever your passage of clock is happen, then only your simulation is going to be ready to execute anything. So until that it will be simply take it as a unknown. So here that's why it shows as a red color. So red color means it is a unknown. So whenever the positive is going to be happen, then only our simulation is going to be happen. It will be negate. So it simply consider it as a unknown. So you can simply write as a Q will be make it as red. Red is nothing but unknown. So see here after positive of clock, here we can observe. So our S value is equal to here. See S value is equal to 1. And what is the R value here? So see this is the R value. So R value is equal to 0. So S is equal to 1, R is equal to 0. Our Q value is going to be 1. But observe in this block diagram it will be 0. So why it is 0? You don't forget about this. So your reset value is equal to 0 here. Sorry, reset value is equal to 1 here. So whenever your reset value is equal to 1, so your output should must be a 0. It doesn't care about what are the inputs, what are the things, it doesn't care about. So that's why your value is 0 here. So next passage of clock here, it will be happen here. So you can cross check again here. So your S value is equal to 1 and your R value is equal to 0. So if S is equal to 1, R is equal to 0, our Q value is going to be 1. So see here your Q value is going to be 1. So Q value is equal to 1. Like that you are going to cross check whether your waveform is correct or not according to your functional table. Like that you are going to cross check. So again next passage of clock will be happening here. So see here your S value is equal to 1 and your R value is equal to high here. You can observe this line. So your R value is equal to 1. So 1 S is equal to 1, R is equal to 1. It is our invalid state, means Q value is going to be X. So that's why it make it as a Q value is equal to X. That means red color we are going to observe here. So it is our test bench code. It is our output form, output waveform. So according to that we can say that our design code is correct. So you can try this. If you have any doubts and if you get any errors, if you don't understand any simple line also, you can comment on it. I can give separate explanation for that. If it maybe take a few seconds or few minutes or some 1 hour also, I take a time and make a separate video. So I think it's fine about, and thanks for watching. Thanks for supporting me, and then bye.